Hai, Assalamualaikum warahmatullahi wabarakatuh. Alright, today we're going to continue with chapter 3, Electrochemistry on physical chemistry. So these are the content of the topics. We're going to learn on electrochemical cell and also cell reaction, what is electropotential, and also standard hydrogen electrode, which is She electrode. And also we're going to learn a bit on EMF, electromotive force, and also spontaneity determination, how to determine the spontaneity, either the reaction is spontaneous or non-spontaneous, and also a bit on Nernst equation. From Nernst equation we have to determine the pH, the concentration, and also the Kc. Right, and then last but not least, we're going to learn a bit on electrolysis and also its application in battery, in electroplating, and also in corrosion. So first thing first, let's know about redox or oxidation reduction reaction. This redox basically a reaction occur in many chemical and biochemical. So it has combustion reaction and also photosynthesis. For example, photosynthesis is also involved redox, where oxidation and reaction occur simultaneously. Same goes to the combustion reaction. And in biology, for example, you learn about mitochondrial respiration, where it occur simultaneously on the same time. And also methane monogenase, also it has redox reactions. Okay, on chemistry, in here in electrochemistry, we just want to focus on how oxidation reaction take place in one pot or in one simultaneous reaction. For example, in this case, oxidation, as we know, oxidation is meant by loss of the electron from one reactant. Okay, so for example, this one we have N in term of solid, okay, has been oxidized to N plus, and also it produce E here. Okay, this is minus sign. Okay, this is oxidation of half reaction, while reduction meaning that you're gaining the electron from the other reactant. For example, chlorine, okay, gas can gain 2 electrons to become a chlorine minus. So this one is known as reduction half reaction. While we combine these two half equation, we can get a net reaction. Net reaction is Na 2Na plus with Cl2. So what you got in the end is 2Na plus 2Cl2. So you have to time this equation with 2. Right, so that's why everything has 2 here. Okay, so note in mind that oxidation and reduction always occur together. They cannot go by one hand only. For example, okay, it have goes to together. Right, so if you are, for example, you undergo process of reduction, so means that kind of substances is actually oxidizing agent. So substance that accept the electron, okay, it takes electron from another substance, it itself will reduce, process of reduction occur, and then it's also known as electron acceptor. So for example, Cl just now, Cl is undergo reduction, so Cl is accepting electron. Cl also known as oxidizing agent. Okay, same goes, okay, the vice versa for reducing agent. So means that the substance that donates electron, it will release electron to another substance, it itself been oxidized. For example, just now we have sodium. Sodium has been oxidized to sodium plus, where itself donate the electrons, okay, to become Na plus. Okay, so it itself is electron donor. Okay, then when we talk about spontaneous, we have a copper wire is placed in solution of silver nitrate. Okay, silver nitrate spontaneously precipitate, while the copper ion spontaneously form, as evidence in blue color. If you look at this one, for example, we have reaction of copper. Okay, copper react with silver nitrate. Okay, silver nitrate, for example. Alright, so what you got in the end, you got copper nitrate. Okay, copper nitrate also. this one, copper charge is 2 plus. Alright, so this is 2 plus here. Okay, and then what you got is copper nitrate and silver. Okay, so that can be proven from this figure. If you look at here, copper itself is kind of solid. Okay, kind of wire. When you put in a silver nitrate or argentum nitrate is kind of liquid here. What you notice, the occur process of redox happens spontaneously, where it shows you the color of the solution here. Argentum nitrate turns into blue, so means that copper from here has been oxidized to this one, alright, to copper nitrate, while silver itself has been reduced to here. So you got the kind of what we call here, what we call frosty here, okay, rusty here. So you got this one, alright, so that's why the color turned to blue, and this one rusty silver turned into this color. Alright, uh so voltaic cell, we can use that energy to do work if we make an electron flow through external device. Normally we have to connect our strips, okay, our strip with the external device here, for example the wire here towards the electrometer, right? And then this setup is called as voltaic cell. So this is a real structure of voltaic cell, where you can have two electrolytes, different electrolytes here, and then you have two different strips, okay, either anode or cathode, okay, and then you also have voltmeter here, and also have wire connect between these two strips. And not to forget, you have this kind of U tube, okay, salt bridge. This is known as salt bridge in order to connect the both electrolytes. Okay, normally oxidation occur at anode. Okay, this one, oxidation occur at anodes and reduction will occur at cathode. Oxidation means that process of release of electrons. Okay, so from zinc to plus and copper to plus, gaining the electrons. So you got the process of reduction. So reduction is occur at cathode. So next, we use salt bridge, usually in a U shape. Okay, it's going to salt solution to keep the charge balance. So cation move from cathode to the anode, and anion will move from anode to cathode. Right, so this is what happened based on zinc copper reaction. It's easily to remember this. Oil rig, redox is in term of oil rig. Oxidation is loss, reduction is gain. Alright, so who gaining the electron, who lost the electron, you can look at here. So zinc lost 2 electron in order to oxidize, right, to become zinc 2 plus, while copper is gain 2 electron from the zinc here, alright, to become copper 2 plus. So that's why the color will be changed here. Okay, so you must also know oxidation half reaction, which is zinc to plus, and also copper to plus, reduction gaining 2 electron to become copper to plus. So overall reaction can be written as this. Okay, so this is what happened when you lost. So meaning that zinc strips, basically there is no tiny atom or molecule deposit on it, but in the copper strips, you can see that more atom is start to deposit on it. So this means that copper receive more electrons, and process of reduction is happen. Okay, so we go a bit on characteristic of voltaic or galvanic versus electrolytic cell. So if you look at voltaic cell, basically just have anode on oxidation, cathode is on reduction. Same goes to this. Electron flow from anode to cathode, same goes to this. But okay, a little bit different here. What is different here is what is different? Energy is released from the spontaneous reaction. System does work on surrounding. So energy is released from the spontaneous reaction. This one, energy is absorbed to drive non-spontaneous reaction? Yes, it's correct. That voltaic reaction, we have spontaneous reaction occur, while electrolytic cell, normally non-spontaneous redox reaction occur. So normally surroundings is power supply do work on the cell. This one surround system do works on the surrounding. Okay, energy has been released, so this one energy has been absorbed inside. So this is common voltaic cell. We have common alkaline flash battery, lead acid battery, calculator battery, which is made up from mercury, lithium ion laptop battery. Alright, electric eel is can have around 5,000 cell in 6-speed eel, which is around 750 volts per eel itself, and nerve or giant squids across our cell membranes, they have their own voltage. So all the voltaic cell has their own voltage, which one could be a more higher and which one is lower. So I want you to do this on a learning check by yourself. So identify the half reaction that occur at the cathode and anode in this acidic solution. You are given overall equation as this, and from this you have to identify which one will undergo oxidation, which one will undergo reduction. Okay, so in this case you have to look at chromium trioxide to become chromium 3 plus, while mangan dioxide become mangan tetraoxide here. So what we can say here, okay, how many electron has been transferred here. Okay, in this case, alright, so chromium become chromium 2 plus, means that chromium will accept 3 type of electrons, okay, to become chromium 3 plus. And then in order to balance it, you have to balance with hydrogen and also H2O. So how to balance this? So you look at this one, we have 3 oxygen here, okay, so means that you got 3 H2O at the back. This is like balancing acid base. Alright, so you have 3, you put 3 H2O at the back, so means that you have 6 now, 6 of hydrogen. So you have to balance here with the hydrogen itself, with the 6 hydrogen. Okay, the rest now is balanced, so means that when it's accepting of electron, process of reduction is happen. Remember, all break. Okay, oxidation is loss, reduction is gain. So it's gain 3 electrons, process is reduction. Meanwhile, in the second equation, we have mangan trioxide. Okay, mangan trioxide to become mangan tetraoxide. So means if you look at here, so for example, M2 to NO4, mangan O2 to mangan O4, what you have to put here first is, let's say you put 3 electrons, okay, 3 electrons here. So now you balance this one with H2O, while you balance on the right side with H. Same goes to this, you put 2 H2O first, for example. So now you have how many oxygen? Oxygen 2 here equivalent to oxygen 4 here, so it's balanced. So next you have 4 hydrogen, where you need to balance the extra 4 hydrogen on the right. Okay, so this process, as is loss of the electron, okay, loss of the electron, the process is oxidation. Oxidation is loss. Okay, so cathode normally occur at the reduction, while anode is occur at the oxidation. So this is the half equation is. Okay, for electron flow, at the copper end, 2 electrons are giving up. For example, copper to copper 2 plus. Okay, oxidation is loss. Okay, loss of electron here, travel across the wire of silver half cell, where it's gain 2 electrons to become argentum plus. Right, so if you look at here, actually this process occurs simultaneously when it asks what happened to the charge in each half cells. So meaning that at this half cell, what happened is argentum going to gain 2 electron, while copper going to lose 2 electron, and they happen simultaneously. Alright, okay. Actually, on charge condition, we have 2 types of charge conduction, where it can give conduction. First is metallic conduction. This is external to the cell. Electrical charge is transported from one electrode to another by movement of the electron through the wire. This is how metal conduct electricity. And number 2, we can also conduct electricity through electrolyte. So electrolytic conduction is happen only in the electrochemical cell. The electrochemical charge is carried through the liquid by movement of the ion. It transport the electrical charge also by the ion. Okay. Alright, so I will stop here.